So your second half of your lesson on 2.5, we're going to be solving rational equations here. And we must solve through algebraic methods. There is a moment at the end of the lesson where we talk about how we can use our graphing calculator to either help us on applications or possibly check work. But you must be able to solve these completely algebraically, because when you get to the point of having extraneous solutions, I want to see those extraneous solutions as well. So these first two examples are already done for you. But what I want to jog your memory about is back in Algebra 2, when you had a rational equation, that meant you had an equation that you're trying to solve, but in at least one of the denominators you had some variable component. So like here you have x minus 4 in a denominator. So to bring back an old concept for you, if this is your equation, tell me the one thing that x can't be. I can't have x equaling 4 at the end of this problem. So what I like to do to start these questions is kind of jot down what are my excluded values, is what we called them, but you guys know them as domain interruptions. If we end up doing all this work and get x equals 4, we're going to have to cross it off. All right, so here's how you solved it. You looked at your denominators, and you decided to come up with, hopefully, a least common multiple. I think she called it a least common denominator here, but same concept. Least common multiple of your denominator. Now, the idea was to shoot for the least common multiple, because if you have too many terms, like you haven't done your factoring, and there's some factoring terms, your work on the next step is going to be like unbearable. So you want to make sure you shoot for the least common multiple. So then your Algebra 2 teacher, or your Honors Algebra 2 teacher, would have you put big parentheses around the whole problem. And I know some of your Honors Algebra 2 teachers last year had you keep the denominators throughout your work. I'm going to show you a technique today where you can lose your denominator right away. I'd like you to practice it that way instead of keeping the denominator. And then you take whatever your least common multiple was. So in this case it would be an x minus 4. And you distribute it to every single term. So you're doing this, and you're doing that, and you're doing that. So we're going to have a couple examples on our notes today where we go all out, and we do this like Algebra 2 style, where you write the LCM in front of every single factor. And then I'm going to show you guys a shortcut, because y'all are capable of handling a little more mental math than your typical Algebra 2 student. So they're going to solve the question next. Look what happened here, though, guys. This x times x minus 4, they have yet to distribute it, so that would be your job. So x squared minus 4x. But look what's happening in this middle fraction. The 8 over x minus 4 times the LCM of x minus 4. You see that the x minus 4s are going to cancel. So you just have a minus 8 in that term. And then 11 times x minus 4, you'd have to go through and distribute. So then, of course, it's PreCalc, which means we're more than likely going to have a quadratic on all of our solving. So you're going to have to get it in standard form. Most of these will solve through factoring. Once in a while, you get one where you have to use another method. But factoring works on pretty much all of them on our notes today if it's a quadratic. So standard form, x squared, let's subtract that over. So minus 15x, and then add the 44 over, plus 36. And 12 and 3. So x minus 12 and x minus 3. Now remember, you're still trying to solve your factors, guys. So the solution to x minus 12 is x equals 12. And then the solution to x minus 3 is x equals 3. Now before I get all Algebra 2-y and I just box in my answers, I got to go back and revisit the concept of extraneous solutions. The one thing that we couldn't have was x equals 4. Did you get x equals 4? No. So you get to keep both answers. So you don't have to go through a full-out check on these questions. As long as you don't get what we call the excluded values, then you're good. So this next one's also done for you. However, I don't think this work looks really exciting. So Mrs. Hoffbauer, bless her heart, wrote the entire problem with the LCM right in front of each term. And this is how we originally taught this to you in Algebra 2. So when I went to my Algebra 2 kids, I had them write the LCM over 1 as well. And then I had my kids do this blob method. So like I had them take a highlighter or a marker, and then each one of these multiplication questions was its own little simplifying question. So like this green blob, and this green blob, and this green blob. So in this first green blob, something better cancel, because the whole point of you using an LCM is to knock out denominators. So does anything cancel or reduce here? Yeah, the x minus 2s are gone. And then 6 divided by 3 is going to reduce to a 2 over 1. So I'm just going to kind of sneak the 2 right here. There should be nothing left in your denominators after the step besides a 1. Now be careful. The 2 still has to be multiplied by that existing x plus 1. We'll get back to that step in a minute. All right, this next green blob, what cancels? The 6's. So you still have x minus 2 times the 5x. We'll come back to that in a minute. And then this last green blob, x minus 2's are gone. And you just have, technically the 1's cancel, guys, but 1's never truly cancel. So we have a 6 left over here. So in this first green blob, you have 2 times x minus 1. So they would have written down a 2x plus 2 equals. And then over here, distributing the 5x here and here, gives them a 5x squared minus 10x. And then 6 times 1, better known as plus 6. So this is where you would pick up in the work here. They didn't really show all that canceling because it's a little hard to type all that. But then, of course, it's a quadratic, so then we go through our math. We'd find the factors and solve. And turns out x equals 2/5 and x equals 2. Now, I kind of skipped this step, but way back at the beginning of the question, tell me things that x cannot be. Oh, x can't be 2. Now, 3 and 6 don't have variables, so they're not going to be a problem. But x cannot be 2 because you'd get a divide by 0 right there. So over here, what you're going to have to do then on your solutions is cross off x equals 2. You'd have to write ext, meaning it's extraneous. So the only viable solution is x equals 2/5. So those are the types of questions you're going to see a lot of today. This first one starts off real nice and easy, guys, so we're not going to have to show tons of work on this one, but look at your denominators, and this one's very boring. There's only a single denominator that has a variable. Tell me the one thing in the world I can't have for m when I'm done with this question. I can't have 0, so just keep that in mind. When we go to solve, if we get 0, we're going to have to cross it off. So then, I'm going to put big parentheses around the entire equation, and I'm trying to knock out all of my variable denominators, or all of my denominators in general. I only have the m to cancel out, so this is a very boring question. You're just going to multiply everything by an m. So you, and you, and you, and you. So that very first fraction, m times 15 over m, the m's will cancel, and you get 15. M times m will be m squared, plus 8m equals 10m. Of course, it's a quadratic. So you want to bring everything to one side, get it in standard form. Most people will just subtract the 10m over, which is fine, except I don't really like quadratics that have negative lead coefficients. So when I go to collect all my like terms and write it in standard form, probably going to do one more step before I try factoring. I'm going to hit everything by a -1, or you can consider this multiplying or dividing, it doesn't matter. Basically, I'm going to change everybody's sign. So, new problem is m squared plus 2m minus 15. And of course we factor. So, m plus 5m minus 3 are your factors, but then you go back, remember, you have to solve, so m equals -5. And m equals 3, and before I commit to these answers, I go back and make sure I don't have one of my excluded values. I just can't have 0. Everything else is fine. So you are good. So there's a case where not really tough algebra did come up with 2 solutions. They both work. Keep them both. Oh boy. All right, your denominators. I see a b minus 3. I see a b. And then I see another b minus 3. So when I ask you for a least common multiple, that's a listing of everything that you need to knock out. So what do you need to knock out? A b and a b minus 3. So your LCM is b times b minus 3, and you want to always keep that in factored form. Now here's where, this is probably the only problem I'm going to do the quote, the long way. So if you have another colored pen, I might suggest you use it here because you will have room to do your math. I'm going to write the b times b minus 3 in front of each fraction from the original problem. So b times b minus 3 over 1 is being multiplied by this first fraction of 4 over b minus 3. Now you'll notice that I often add my own sets of parentheses around polynomials. That's to just keep my work a little more organized than normal. All right, then you're going to distribute another b times b minus 3. And you're multiplying that by 3 over b. And then you're going to distribute a third b times b minus 3. And he's being multiplied to that original negative 2b. Again, I'm going to add parentheses here. Negative 2b over b minus 3. All right, I'm going to go old school on you. Green blob method. So I'm going to take a green marker. If you don't have one, you can just literally put a bubble around each of these. Each of these questions are their own little simplifying questions. So when I look at this first multiplication question, tell me what crosses off what cancels. The b minus 3's are gone. So all you have left is b times 4, which I'll write as 4b. Okay, next multiplication question, what cancels? This time the b's cancel, so you have 3 times b minus 3. We'll come back to that step. And then this last one, the b minus 3's will cancel. So you have b times negative 2b, so you have negative 2b squared. All right, so I was safe to just distribute the 3 here. I just know there's some problems coming up where you might want to hold off on the distribution until the next step because there's a lot of simplifying that has to happen. All right, so we have 4b plus 3b minus 9 equals negative 2b squared. Pretty much, I'm not going to say all of them, but almost every single question you encounter in PreCalc on this is going to have a quadratic component, so what a surprise, we have a quadratic. Oh, you know what I forgot to do at the beginning? I forgot to tell myself what b couldn't be. We'll come back to that. All right, so I'm going to add the 2b squared over. I'm going to add these b's together. And then now you have a standard form quadratic. And it totally factors. Awesome. All right, so 2b and b. And then if you put a plus 9 right here and a minus 1 right here, those are your factors. So now I need you to go back and solve your factors. So this first one, 2b plus 9, if you solve that, you'd get a negative 9 over 2. And then if I solve the second factor, I get b equals 1. But since I forgot to do that very important first step, let's go back to that for a moment. Way at the beginning of the problem, there were 2 things that b couldn't be. What were they? Couldn't be 0 or 3. Did you get either 0 or 3 in your solutions? No, so they're both good. Ooh, fun. Okay, that is the last time we do it the long way on the notes where you write out the LCM in front of each fraction, because that gets kind of crazy. So what I'm going to do from here on out is I'm going to show you a little shortcut. Instead of writing down everything, what we're going to write down are just the things that don't cancel. So, on the back of your notes, oh boy, if you look at your denominators the way they currently exist, you're going to have a very intense least common multiple, but it won't even be the least common multiple, it'll just be a common multiple. So here's what I need you to get used to doing. When you look at your denominators, if they're not in their true factored form, then you're going to have trouble finding the least common multiple. So let's go to this one. I know y'all can factor this in your sleep. How do you factor y squared minus 4? That's just y plus 2 times y minus 2. So I can see each factor separately. Now, you want to have the most things in common as possible. And this middle denominator is a little interesting to me, because he almost looks like a factor that we already have, a y minus 2, but he seems to be backwards. So this is a technique in math. If you have what looks like kind of the right polynomial, but it's backwards or the signs are opposite, what you're going to do is you're going to factor a negative out of the term. And then if you factored a negative out of this term here, guys, that changes everybody's sign. So this becomes a negative 2, and this becomes a plus y. What is another name for negative 2 plus y? Y minus 2. So, ta-da, just like that, we have a common factor. Now, this is where it gets kind of crazy. I'm going to rewrite what we have right underneath that, because this is a little confusing on this part here. So you have 2 over y plus 2. That's not different. But guys, when you have a negative and then you factored out another negative, this symbol changes to a plus sign. And then we already did all that work with factoring, so this denominator, instead of calling it negative 2 plus y, let's go ahead and call it y minus 2. So that was a bit of a little algebra trick where I had to manipulate it so that it worked for my problem, and that's one thing we have to learn about in PreCalc, because we need that skill for calculus. I swear, 3/4 of math is just manipulation of your algebra, which is super fun and it feels pointless, but it's all in an effort to make your math easier. All right, so now, guys, tell me the things that y cannot be, since I keep forgetting this step. I can't have y equals 2. What else? Negative 2 would also be a problem. So keep those in mind when I come back to the end of the problem. Alrighty, here we go. LCM, I need to knock out a y plus 2 and a y minus 2. So that is your LCM. Should have wrote that somewhere else. Oops, 2. Alright, so here, this is where I'm going to save myself a little bit of headache. Instead of writing down everything, I'm only going to write down what's left. So when you take this first fraction and you multiply it by the LCM, what's going to cancel? The y plus 2's are gone. So you still have the 2 from the original numerator, and you still have the y minus 2 from the LCM. But the other parts are gone. They canceled. Okay, then you have a plus sign. When I go to this negative, this next term, remember that's not a plus sign. This next term, the y minus 2's will cancel. And you still have a y from the numerator and a y plus 2 from the LCM. And then when you distribute this LCM to the last term, both the y plus 2 and the y minus 2 are going to cancel out. So all you have left is the y squared plus 4. So this is what I'm talking about, where like sometimes kids try to jump a step and they distributed the 2 already and they distributed the y already. You can. I'm just telling you, that's where people mess up. So I don't know if it's a wise move. So let's distribute now as a separate step. So you have 2y minus 4 plus y squared plus 2y equals y squared plus 4. And oh my goodness, I thought I had a quadratic per the usual, but when I look closer, I think the y squareds are going to cancel out. So you actually don't have a quadratic anymore. These are gone. You have a linear, so you want to bring everything, all the y's to one side, all the constants to the other. You're just going to solve it like normal. So I'm really worried about messing these up at the last minute. I'm going to go a little slow. 4y minus 4 equals 4. You're going to add 4 to both sides, of course. Whoops, that's ugly. 4y equals 8. And y equals 2. And I'm so excited after all that work. I'm going to go box in y equals 2. And then I'm going to get it wrong. Tell me why. Way at the beginning, we said y can't be 2 or negative 2. Those are excluded values. So what you're going to need to do for me is show all this work, because that is part of the process. And at the very end, you're going to come through and tell me that this solution is extraneous. So if all of your viable solutions are extraneous, what does that mean? That we have no solution. Very good. Guys, no solution is a solution in itself. So don't feel like you wasted your time. All of that is part of the process. Okay. This one's going to seem like a vacation after that last one. All my denominators are like their own factors. X and x plus 3 are 2 separate factors. So when I go to multiply through by my least common multiple, I need to knock out an x and an x plus 3. If you're wondering why I'm putting the LCM to the right of the equation, it's because it doesn't matter, and it's just easier for me to read my notes later when my LCM is not like on top of something else. Alright, so that first fraction, the x's are going to knock each other out, but you still have the 60 from the numerator, and it's still being multiplied by the x plus 3 from the LCM. Now on this next fraction, the x plus 3's are going to knock each other out, So you still have a subtract 60 from the numerator, and then it's going to be multiplied by the x from the LCM. And then in our last fraction, I mean, you can say the ones cancel, but they really don't ever cancel. You have nothing to cancel, so you just have x times x plus 3. And again, I know your first instinct is to write down x squared plus 3x. And you're not wrong to do that, but that is a place where people mess up big time. If you remember from Algebra 2, these are the questions where you would have a lot of work, and then your teacher would come back to you and say, you messed up on like step 1, and then you'd have to erase all your work, because that mistake follows through your work. So, slow is the name of the game here, guys. Let's distribute now. So 60x plus 180 minus 60x equals x squared plus 3x. Oh, what do you know? You have a quadratic. So this time, I don't like when my quadratic term is negative. I'm actually going to bring everything over to the right side. So, but this is kind of nice. The 60x and the minus 60x are on the same side, and they're going to cancel each other out. So all you really have to do is subtract that 180 over. So 0 equals x squared plus 3x minus 180. Now, 180 has a lot of factors. Does it divide by 15? Someone try that for me? Is it 12 and 15? Oh, cool. That works. All right, so factoring, how about x plus 15 times x minus 12? And then when you go and solve your factors, oh snap, I did it again. Remember how I was supposed to, at the very beginning, tell me things that x can't be? We'll come back to that. All right, so x equals negative 15 and x equals 12. But if I go back to the beginning of the problem, the two problems I was going to encounter would be x can't be 0 and x can't be negative 3. Did you get either one of those? Nah, so your answers are both viable. Keep them. That was fun. All right. Oh, this next one's a hoot. There's quite a bit of workspace here on number 5. So if you feel like you need to go back to your roots of like writing the LCM in front of each term, this would be a good question to do that on. I'm probably not going to though. Let's look at our denominators. They're already factored in their own individual pieces. Can you guys tell me, so I don't forget again, what x cannot be at the end of this problem? Can't have 0. And what else? Negative 3. Now this 4, it is a component of the denominator, but it's not going to give you any sort of extraneous solution because there's no variable in it. Okay, so keep that in mind at the end of this question. We can't have 0 and we can't have negative 3. So, let's talk about LCM. Because I don't like fractions, I would like to knock out not only the variable parts of the denominator, I want to knock out everything in the denominator because I don't want a single fraction here until the end. So tell me things I need to cancel out. A 4, and x, and an x plus 3. So distribute all those. So in this first fraction, the x's are going to cancel. But you still have an x plus 3 from the existing numerator, you still have a 4, and you still have an x plus 3 from the LCM. So what I'm going to do is I'm going to write down the 4 and the x plus 3 from the LCM, and then it's still being multiplied by this x plus 3. Notice, I snuck in some parentheses around that. Okay, the next term, the x plus 3's are going to knock out. So you still have a 7x from the numerator, and you're still trying to multiply it by a 4x. Come back to that. And then equals, when you hit your last fraction, the only thing that cancels are the 4. So you still have a 23. And you're trying to multiply it by the x from the LCM and the x plus 3 from the LCM. So this part right here, whoops, I don't know why it went black and green. This part right here is where kids typically mess up because they're not really sure what to do with the multiple distributions. So most common mistake, kids come through and they distribute the 4 and then they want to know what they did wrong. Because what they do is they distribute the 4 to the first x plus 3 and then they distribute the 4 to the second x plus 3. Well, now think about what they've done. They've multiplied by a 4, and then they've multiplied by an additional 4. They just multiplied by a 16. Are they supposed to multiply by a 16? No, they're supposed to distribute a 4. So here's what I would suggest you do. I would distribute the binomials together first, and then come back and distribute a 4. So leave the 4 in front for a moment. Quickly FOIL those together, and get x squared plus 6x plus 9. Now the rest of this problem isn't too tricky. That's going to be a plus 28x squared. And it's a 23x that we're distributing here. So 23x squared plus 69x. So now would be a fine time to come back through and distribute that 4. Thank you. Alright, 4x squared plus 24x plus 36, and then you have a plus 28x squared equals 23x squared plus 69x. Okay, definitely a quadratic. We're not going to lose the quadratic term, so let's try to group those together. I have 32x squareds over here on the left, and I have 23x squareds on the right, so let's subtract that over. 32 minus 23 is 9x squared. And then 24x, and you're going to subtract the 69x over. Negative 45x. And then plus 36, nothing happened yet. No combining there. So that's fun. It is a quadratic, but before I start factoring or using any other method, do you notice that there's a common factor of 9? And since we're solving, there's nothing wrong with coming through and dividing everything by a 9. So, new and improved quadratic, x squared minus 5x plus 4. Oh, that's much better. Alright, so you get x minus 4 times x minus 1. And you solve them, and you get x equals 4 and x equals 1. And then that was a lot of work, so I kind of forgot what the excluded values were. So back at the beginning, the only two things I couldn't have were 0 and negative 3. Did you get either a 0 or a negative 3? No, so keep them both. That was lovely. Alright. Who doesn't like a nice application question? I know I love an application question on a Monday. Alright, so this is fun, because this is like an application question. We're also going to use our calculator, because I don't want to do this one by hand. And then it's also a good review of geometry skills. So we have the surface area of the box is what we're trying to find. And we have like a certain amount of surface area that we want. We're going to get to that at the end of the problem. But the first clue is the volume of this box is 625 cubic inches. And the base is a square. And it says use x for the side length of the square. So I'm going to need some labels on my picture here, guys. These are all x's, right, down here? Great. What would you like to call the height? Because they didn't tell me that one. Don't use y. Remember that one time I used y and it wasn't y and I went to go use the calculator and I got really confused? Okay, so something other than y. For height. Oh, h. What a novel thought. Okay. H would be an appropriate measurement for height. Sounds good to me. Now, this is assuming it's a uniform box. That means all these little top pieces are also x's. Keep that in mind. And the very first clue they gave me has nothing to do with surface area, but it is a clue I'm going to need, because right now I have too many variables, too many unknown things. So it says that the volume of the box is 625 cubic inches. A volume of a box is length times width times height. So knowing everything I know about this picture and this problem, the volume is 625. What would the length and width multiplied together look like? X times x, better known as x squared. And then, you crazy kids, you called height h. That was smart. Do me a favor and solve for h. So you just divide the x squared over. So h is 625 over x squared. So you might ask yourself, why did she make me do that? A little thing called substitution, guys. We're not going to use h for height anymore. we're going to use 625 over x squared for height. Here's why, because they want to know the surface area. Well, first we have to set up surface area. And then they told me a target surface area in an upcoming part of the question. And then we're going to use our calculator to figure out how wide the box should be. All right, remember how to find surface area? And I don't mean like the formula you have memorized, because I do not care about geometry formulas because they're stupid to memorize, some of them. Surface area being one of them, guys. Surface area is just you adding up all the surfaces. So do you have to memorize a formula for that? No, because y'all passed kindergarten, so you know what a rectangle looks like. And then you pass 3rd grade, so you also know how to find area of a rectangle. We got this. Here we go. The base here. What would be his area? X times x, better known as x squared. How many of those blue bases do you see? 2. So his surface area would be 2 of the x squareds. And then it's a little misleading because of the dimension, but what's the area of the front of the box? Just use x and h for a minute because h is weird, I know. It'd be x times h, right? xh. How many of those green panels are we going to have on this box? 4. Okay, so you have plus 4 xh's. Well, this is fascinating, guys, but I'm not going to be able to type an h into my calculator. So remember all that work we did a minute ago. We're not going to use h. We're going to use 625 over x squared. So get this guy out of there. And then there's one more clue. It says your surface area is supposed to be 512.5. Okay. So 512.5 equals 2x squared plus 4x times, and we're not using h anymore. We're using 625 over x squared. Now this is what I love about my calculator. Calculator does not care how ugly you just typed. It can handle it. So what we're going to do next, we're going to type all this baby into y1 and all this baby into y2. So here's the trouble with using graphing calculators to solve rational equations. The window is eminently important. And if it's an application question, I can come up with a window a little easier than a traditional algebra question. X represents the length or the width of the base of the box. So I'm really bad at visualizing dimensions, but like I can't imagine the width of the box being any more than, like definitely not more than 20. Because if it was like 20 by 20, the base itself is already 400. So like that's going to be way too big. So when I go to window, you need to control the x's. You need to give it an appropriate x window. Even if you're trying to use zoom fit, you can't just hit zoom fit and hope for the best every time. You have to set up your x's to be appropriate. So last class we went with 0 to 20. And I'll give you a little insight, guys. 20 is too big. 20 is too big. So you want to pull it back a little? Let's go 15. And even so go 0 to 15 for x's, and then choose zoom fit. Although I really don't think I had to do that either. I forgot about the other part of the function. You guys remember what we're trying to do? We're trying to see where it hits the line 512.5. So I kind of already know what I want my y's to be. I want my y's to surround 512.5. So scrap that. No more zoom fit, guys. That's silly. Let's go 400 to 600. Will 512.5 be in the middle of those two? Sure will, Abruzzo. Alright. Now those of you who did hit zoom fit, you probably have a decent picture. But like mine's super better. Look at that. So what I found in first hours when we did zoom fit was 0 to 20 for x's. We had a really cruddy picture. So what we had to do then is go back to the window and adjust the y's anyways. And then I went, oh duh, Abruzzo. Like you're trying to cross 512.5. You didn't even have to zoom fit. Now guys, notice there's 2 intersection points. Let's find them. So choose intersect. Enter, enter, enter. And it's going to default to the closest one. So I'm going to jot down that answer, which I think I did. Yep. 5.54 Jot that down. And then let's go find the other one. Okay, second trace. Intersect. And then before you hit enter the third time, you're going to need to hop over so you're closer to the other intersection point. Otherwise your calculator is going to default to the closest one again. 12.5. Oh wait, jot that down. So this is where the manufacturer is going to have to make a decision, basically. Alright, I already forgot what 5.54 was one of them. And then 12.5 was the other one. So this box, if we use 5.54 as the bottom dimension, this box is 5.54 by 5.54 by, no, you're going to have to plug that in for me. What's 625 divided by 5.54 squared? Ish. $20.4-ish? Does that come out to that? Okay. Okay. So that could be the dimensions of the box. Or, according to our calculations, the base could be 12.5 by 12.5 by, now this time, plug in a 12.5 right there. Okay. So this is where they have to make a decision. What type of box do they want? Do they want the base to be, five-ish by 5-ish and then like a really tall box? Or do they want a larger base and a shorter box? So I guess it depends on what they're looking for. It'll probably depend on cost of packaging. It'll probably depend on cost of production and storage for people. What does your customer want? I mean, this was, in its essence, not a really challenging math problem, but when you throw in all of the human components and the financial components to it, it becomes a very intense decision-making process, right? Because the whole point of the company is to make money and lower cost. So these are the kind of questions you see a lot in applied calculus. Obviously, we didn't do calculus, but they would apply calculus and they'd determine for the company, like, how are we going to limit your cost? How are we going to maximize your profit? All right, so your homework is, out of the book, those numbers. The last one is done on your calculator, so just work to find a good window, please. And then the other ones are all algebra, so remember, your answer key has only answers. There's nothing but answers on the answer key, so you're going to show all your work. All right, good luck.